Hello everyone, and thank you for joining us to explore how to avoid common pitfalls in spatial analysis. As always, my name is Alex Martinick, Esri's Commercial Industry Specialist for Financial Services and Insurance. My primary responsibility is managing Esri's strategic initiatives for risk management. This encompasses everything from traditional insurance exposure management to corporate security and business continuity. Over the past 3 years, I've been helping our users from both government agencies and the private sector transform their core operations using location so they can make well-informed decisions. I'm joined today by Russell Sands, who is a solution engineer for our insurance team. Russell is one of our technical leaders here at Esri, focusing on how GIS can revolutionize traditional workflows in underwriting, risk modeling, and claims. And over the past year and a half, he's been shaping our geospatial solutions for that space. Prior to joining Esri, Russell worked at AIR Worldwide for 3 years as a GIS analyst, and he's joining us today to talk about the best practices for identifying and overcoming common statistical fallacies. Now, today we're going to be talking a lot about data. If you viewed our previous sessions, you understand the importance of establishing context when presenting complex findings to decision makers. This is increasingly important as data has become the most valuable commodity for businesses. In a recent survey conducted by PricewaterhouseCoopers, 90% of executives polled said that data played an important, if not integral, role in their daily decision-making, not to mention its use for shaping core strategies. While data can help us deepen our understanding of an issue and ultimately make better decisions, we must be cognizant of 2 issues. The first is that contrary to popular opinion around analytics, data itself is not objective. 2 analysts with similar backgrounds and trainings can examine the same data and extract different pieces of information from it. Why is this, you may ask? This is because data is ultimately subject to interpretation, whether by an analyst or by the output of a tool or data model. And on that note, there's no such thing as a perfect data model, since each one is based on the experience, expertise, and biases of their creator. This lack of objectivity does not mean, though, that data models aren't helpful. Quite the contrary. What we're here to talk about today is the best practices for mitigating and minimizing the effects of misinterpretations. After all, small errors can add up, especially in the context of the global insurance market. If you walk away with anything today, let it be this. That's that statistics lie. I recall early on in my career working with statisticians who constantly looked at data from multiple points of view, each one telling drastically different stories. When I asked about the value of data given its ability to misguide and its propensity to tell stories like this, and what I was told didn't quite resonate with me until later on in my career, and that is that the secret is discovering the point of view that's valuable to you. Now, I'm not talking about the one that just makes you look good, rather the one that answers your question. As we look at the insurance market, there's little to no room for miscalculations, as even small errors in risk accumulation could result in millions in realized losses. To overcome this challenge, you have to first and foremost understand what it is you need to know. Then you can properly define a question that seeks that point. And this may seem a little strange to say, but you have to question your questions to keep on track. Find the need behind the need. You may set out along a statistical pathway that answers your question, but it doesn't solve the problem you have. In those cases, you have to reevaluate what is the information that's actually valuable. What are those genuine insights that help transform that core process? And don't settle on the first results. Constantly challenge your findings to determine if there's a hidden third variable that could have influenced your results. Oftentimes we may find a simple low-hanging fruit type of connection, and we'll think that that's the ending point, but that might just be the starting point of more questions to come. Lastly, realize that especially within insurance and risk management, the data we're dealing with is incredibly complex and multidimensional. Always seek alternative sources of data to normalize and support your findings, to challenge, question, evaluate, analyze, repeat. And be prepared for multiple answers to the question that you didn't expect. It may not be one thing, it may be several things, and none of them were initially within your initial scope. The more complex the problem, the more likely you'll encounter a multivariate cause. So with that today, I'm going to turn it over to Russell to show us how to identify and avoid these challenges. And keep in mind the question that we're trying to solve and how our analysis is really driven by that question. So with that, Russell, I'm going to be handing it over to you.
Thank you, Alex. And, hello, everybody, and thank you for having me back today for our latest webinar. What I'm going to be talking about is really a continuation of what we discussed in a previous webinar. Previously, we illustrated data aggregation techniques and how we are able to share insights in ArcGIS, but we didn't really go any further than that analytically. Today, I'll be demonstrating some of the ways that we can avoid common mistakes that analysts make in order to derive more meaningful insights from our spatial data. And so, just like Alex mentioned, our tools, our spatial analytic capabilities, are only valuable if we know how to use them, and they're most valuable when we know how to use them properly. If we don't, it opens us up to the risk that the outputs of our analyses are inaccurate, incorrect, or otherwise misrepresent the truth. In this case, what we've produced may actually be worse than having had no information at all. And while this should be a matter of concern, it really shouldn't deter us from performing analytics to begin with. And that's because this principle is true of any capability we might leverage. Everything from spreadsheets to charts and even documents carries similar risks. So the real question is, how do we avoid these common pitfalls in spatial analysis? And that's really by understanding what the best practices are and the suite of tools available to us. That way we can be more confident as analysts that we're applying the correct tool and visualization to answer the questions that we're asking. Today, we're going to be working through this in the context of our accumulation data. Understanding where our risks are accumulated or concentrated is fundamental to effective risk management. Being able to visualize that information can be an invaluable resource for our stakeholders. However, that's provided that the information is presented effectively. And when we visualize the geocoded location of our policies, we often end up with a map like this one. If the questions that our stakeholders are asking are things like, where are we most concentrated in the LA area? Or where are the opportunities to expand our business? And where might we want to limit our underwriting activity? Then we really can't present a map like this one to them. They wouldn't be able to use it to answer even these fundamental questions about our exposure. They'd simply be lost in this sea of blue dots. That's because when we present our data this way, the volume of data on the screen makes it impossible to extract that meaningful information. We could create an interactive map that would allow our stakeholders to zoom in. But even when we zoom in to a more local level, we haven't really solved the problem. It's still very difficult to see the signal through the noise. Certainly, there's definitely some new patterns that are emerging here. For example, I can see that my policies tend to align to streets and be concentrated in neighborhoods. But if I was going to take some time right now to poll the audience and ask what the difference in our exposure between an area like Santa Monica versus Beverly Hills is, there's not really a practical way that you could answer that question from this map. It would be pretty much still guesswork. A common technique for overcoming this problem is to use something like a zip code, as we've done here, or another administrative boundary to aggregate up our policy data. However, as we discussed in our webinar on uncovering the hidden insights with the science of where, there are some significant downsides to this technique. The administrative boundaries that we define tend to only communicate how society is organized. And this means that oftentimes they highlight the patterns, barriers, and pathways that we perceive in our daily lives. And while this might be appropriate for a lot of practices, such as identifying target markets for marketing purposes or working within local regulations, when we're looking to derive more detailed risk analytics, we need a finer-grained approach. And that's because the hazards in our environment and the natural disasters that are going to impact our customers, they don't occur with respects to the boundaries that we've defined. And what we can do is create something like we're seeing here. We can create an even tessellation, like the grid we're showing now, to help overcome the problems with our administrative boundaries. In this density map, we're looking at the number of policies within each grid cell. While density maps are a common way to explore our exposure, today, though, it's not going to be our finished product. There are a few reasons that we may want to go beyond a density map, but one of the most important ones is that no matter how good our vision is, our eyes simply can't see statistics. While we can look at this map and see that there are a few areas that have higher numbers of policies, we can't say whether they represent a meaningful concentration. I also want to add that while in our previous webinar we looked at the sum of total insured value, today we're going to be using the count of policies for reasons that should become clear later on in this analysis. But the question now is, how do we go beyond a density map? Well, ArcGIS enables us to uncover meaningful insights by leveraging tools that perform advanced geostatistical analyses. These tools incorporate location to find meaningful patterns in our data. And so what we're looking at now is, on the left, our raw density map, and on the right, the output of one of those tools, hotspot analysis. The hotspot analysis tool classifies our data into hot and cool spots. And in the result, a hotspot represents a contiguous area of high values. In other words, a continuous region where we have a high number of policies. A cold spot represents a contiguous area of low values, or an area with low concentration. By comparing the density map to the hotspot map, we'll see what appear to be some pretty significant differences. In the density map, only the inner urban core of Los Angeles really appears to be highly concentrated. But if I swipe to reveal my hotspot analysis result, what I can see is that almost this entire area has been identified as a statistically meaningful high density area. Another thing that you might note, if we return to the density map, is that while some cities, such as Riverside, in the density map don't appear to have a particularly high number of policies, especially by comparison to Los Angeles, what we can see in our hotspot result is that the tool has identified that relative to the surrounding area, Riverside represents a meaningfully high concentration of policies. And this is an observation that our stakeholders and we as well may have missed in our density map. But some of you who are watching this probably are noticing something that represents a little bit of a problem. And that is that these clusters we've found aren't necessarily surprising. They were centered around urban areas where we would likely expect, even without running a tool, that we would have a high concentration of risk. And we can take this extreme example of Las Vegas as a representation of this. Is the tool that this hotspot that we found interesting? And importantly, is it meaningful, or should we make a business decision based on the hotspot we've identified? And that's probably not a great idea. If we reveal the satellite image underneath, we can see that, again, all we've done is identify the inner urban area. We found a hotspot in the middle of an empty desert. And this is probably not terribly surprising, and that's because our policy data correlates strongly to where people choose to live. It's the people, their homes, businesses, and assets that we're insuring. And if we were to stop at this point in our analysis and show our hotspot map to our stakeholders, they might be understandably underwhelmed. So we need to find a way that we can potentially reveal more meaningful insights in our data. And one way that we can do that is by leveraging additional data that's available to us, such as the data that's available in Business Analyst. From the product page here, we can browse the over 15,000 data layers available by the particular category or use case, but I can also search for a particular term of interest. In this case, I'm going to search the data browser for variables that are related to insurance. In this list of categories, I can see that I have some market potential data. If I scroll through this list, which contains many different variables describing the market potential for insurance, one of them that's available to me is the total number of people who carry homeowners insurance. Working with this data layer and the grid that I've already created to create my density map, I can actually aggregate my business analyst data to the same grid. And I can then compare that result to my raw density map. So if we examine the pattern around New York and New Jersey and Philadelphia, we can see that the pattern in the number of people who have taken out a homeowner's policy and the pattern in the density in my policies in force is pretty similar. Now, again, you might be thinking that this isn't particularly an interesting result in and of itself. And that's because the number of policies that I write really represent a subset of this market potential information. But as an analyst, this opens up some additional options for me to leverage statistical techniques. One of those techniques that's available to me in R and is commonly used in disease mapping is called empirical Bayes estimation. And what this technique allows me to do is to transform my raw policy counts into rates by incorporating information that describes the larger population of policies that I could insure but do not. In this case, it's the market potential data. This technique relies on using count information, which is why we've been working with the aggregated policy counts rather than the sum of total insured value or another metric. And thankfully, performing this analysis in R is easy. And that's due to the tight coupling between R and ArcGIS that's available through the R bridge. By using the R bridge, I'm able to quickly bring my spatial data from ArcGIS into R, perform my analysis that I need to do in R, and then bring those results back to ArcGIS. Once I have my raw density map transformed into rate data, I can rerun my hotspot analysis on the output. Only this time, instead of finding hotspots in the raw density, the tool will identify hot and cool spots in my data that are present even after I've accounted for the underlying population of potential customers. And so the question is this result any more informative? We can use another swipe map to begin to evaluate this. Only this time, on the left, I have the output of my initial clustering, and on the right, I have the clusters that come out of my hotspot analysis tool when it's been run on the rate data. The story in Chicago seems to be pretty similar in the initial hotspot analysis to what we saw in LA. However, if I were to swipe and reveal the hot and cool spots in my rate data, I see a very different pattern emerge. While there are still some areas that are being identified as hotspots, large portions of the region are being identified as not having any significant clustering. And in fact, even though the confidence value is lower than some of the hotspots, some potential cool spots have emerged. So perhaps in my initial analysis, my answer may have been that we want to avoid Chicago altogether. But by leveraging an additional step and thinking more critically about my workflow, I'm able to identify a potential opportunity in Chicago, or at least the opportunity to have a more informed discussion with my stakeholders. And I've done this by going beyond my initial aggregation. If we were to review some of the other areas we've looked at, such as by returning to Los Angeles, we'd see some pretty similar things. While the initial hotspot result shows the entirety of Los Angeles as a hotspot, which we saw before, when I reveal the hotspots from after running the rate tool, I can see that, again, there still are hotspots, but a different pattern has emerged. We could return to some of the other areas, but the results and the questions they pose are really what enable our stakeholders to gain the additional perspective that they need to make business decisions. And as we continue to refine our analysis, we're in a better position to provide those decision makers with actionable insights that may positively impact our organization. The ability in ArcGIS to combine both advanced spatial analytics with statistical ones only furthers our ability as analysts to do so. I'm going to turn this back over to Alex in just a moment, but there's actually one thing that I'd like to add that's a little bit different about the webinar today. And that's that if you found this workflow interesting and you want to learn more about it, or if you'd like to actually perform these steps on some sample data, we've based this webinar around a self-led course on learn.arcgis.com. And at the end of this webinar, we'll be providing a link to the course that we've modeled it on. If you navigate through to that link, you'll find all of the data you need, as well as detailed instructions to test this workflow out for yourself on some sample data. And so with that, I'd like to turn this back over to Alex.
So what does this mean moving forward? Here are our top 5 takeaways that have come from one of Esri's premier statisticians, Lauren Bennett. The first is ask and explore. You need to start with this well-defined question to keep you on the right path moving forward. If you define the question in a way that it ultimately leads you to the results you're looking for to make the decisions, you're on the right track. This also helps you select the right tools for it to model and compute. As we looked at with the visualizations and the various analyses that we could run, the GIS platform that Esri has can do a wide array of things. So make sure you select the tools that lead you to that goal. Don't settle for the low-hanging fruit. Examine and interpret. Challenge your initial results. If Russell's initial question was just where do we have the highest concentration of policies for, say, a disaster response to predict the total insured value in an area when we have a event coming in there, that would be appropriate. But in this particular case, since the question was more along the lines of where are there opportunities, that was the need behind the need, we needed to continue to examine and interpret that data. When you have the results you're looking for, make the decisions. Data and tools are ultimately worthless if they don't directly support your decisions. The best analyses by themselves don't have value. And when you do make those decisions, share your results. Let it be heard, your best practices that you find. Everything that Russell showed today in that workflow was using one of Esri's templated information products, the story map. In about 1 month, we'll be doing a webinar specifically on how to produce story maps and all of the products here, from the swipe tool to our various templates. Everything that Russell showed was designed without coding, just importing the web maps and the data from our internal organization's portal. We'll be talking more about that in about a month. So share your results. With that, as Russell mentioned, this is all based on a course that is at no cost offered to you now. This is Analyzing Crime Using Statistics and the R ArcGIS Bridge. R, for those of you who aren't aware, is one of the premier open source statistical platforms out there for everything from big data analytics on. This course talks about how you can integrate R with ArcGIS. It provides the sample data for you as well and self-paced tutorials at your own pace. To access, please visit go.esri.com/risklessons. I'm going to give a few moments for those of you in the audience that would like to write that down or navigate to that page. There are several hours of self-paced tutorials to build the products that we've showed today. We encourage you to take it. Again, that's offered at no cost. With that, I'd like to thank you all for joining us today.